Alright, so today we're going to be taking a look and learning how to find a percent of increase and decrease. Percents can be used to describe a change. A lot of times you'll hear things in like business and they'll talk about, oh, they saw a 200% increase in business and things like that. So the percent change is the ratio of the amount of change to the original amount. So the percent of change basically breaks down to, you take the new minus the old divided by the old or original. So a percent of increase just describes how much the original amount increased, and a percent of decrease just describes how much the original amount decreased. And it obviously can only be one or the other. So we're going to start by finding the percent of increase or decrease from 16 to 12. So just from looking, I know that it's going to be a decrease because we're going from 16 to 12, so it's getting smaller. So first we're going to find the amount of change. So what percent is, or before we get that, so here we have to find the percent of change, or the amount of change. So it's going to be 12 minus 16, because it's new minus old. So what percent is negative 4 of 16? So we're going to set up a ratio of negative 4 to 16. Now as we look at this, because it's negative 4, we're going to change that to a decimal form, or if we reduce that, that's the same as negative 1/4. In decimal form, it's going to be 0.25. So it's going to be 25%, or negative 0.25. So this is a 25% decrease because we went down. Now it's your turn. See if you can figure this one out on your own. Now we're changing from 15 to 20, so it's an increase. So I'm going to find my difference. I'm going to take 20 minus 15, which is equal to 5. My original amount was 15, so what percent of 5 is to 15? So I'm going to do 5 divided by 15, or that's the same as 1/3, which is really 0.3 repeating. So if I change that into a decimal, it becomes 33 1/3%, and it's an increase. Now let's just look at a real life example. When Jim was exercising, his heart rate went from 70 to 98 beats per minute. What was his percent of increase? So we went from 70 to 98. So first we're going to find our change. So I'm going to do 98 minus 70, which gives us 28. So it's going to be 28 out of the original 70. Those are both divisible by 7. So this becomes 4/10, which is also the same as 2/5, which as a decimal is 0.4. So here we saw a 40% increase. So another way we use percents is when we're talking about sales tax and discounts. So if Sarah bought a DVD player originally priced at $450 and it was on sale for 20% off, we want to know what the sale price was. So first we're going to find 20% of 450. I could set it up as a proportion, an equation, however you want to do it. So if I set it up as a equation, it's going to be 450 times 0.2 as a decimal is going to equal our discount. So if I do 450 times 0.2, it's really going to be 90. So $90 is what we get off, so that's our discount. But they're asking what was the sale price, so I'm going to take my 450, subtract my $90, and I'm going to get a sale price of $360. So let's look at one more example. Mr. Olson has a computer business in which he sells everything at 40% above the wholesale cost. If he purchased a printer for $85 wholesale, what would be the retail price? So first we're going to find 40% of 85. So right now I'm going to use a proportion. So 40%, percents always go out of 100, is equal to x out of 85. If I cross multiply, I'm going to have 40 times 85 is equal to 100 times x. So 40 times 85 is 3,400 plus 100x. We're going to divide by 100. So $34 is equal to x. Now that's not the answer though, because they want to know what's the retail price, and so since it's above, we have to take the 85 and add the 34 for $119 retail price.